In this video, I'm going to take you through writing your first PSoC code. Start by opening up PSoC Creator from the Start menu. Scroll down to find a folder called Cypress. Inside that folder, find the item called PSoC Creator. You might be asked to register, and it's okay to just X out this window. When PSoC Creator opens, your window will look something like this. The first thing we're going to do is create a new project. Click on File, New, Project. Now we need to pick the device, that is our microcontroller, that we're going to be using. Click on the Target Device option, and then click on the first drop-down and select PSoC 5 LP. In the second drop-down menu, choose CY8 C58 LP. This is the device family of the chip that came in your kit. Click Next. Make sure you select Empty Schematic and then click Next again. Now, here is where you get to select where you're going to save your file and what this workspace and project is going to be named. A workspace is kind of like a folder, and a project is kind of like a file within that folder. You can have one workspace with multiple projects or multiple programs within that same workspace. I'm going to name my workspace Robotics 1, and I'm going to name the project Introduction. You can also click here in order to choose a new location where you want to save your code. After you've selected where you want to save your code, click Finish. It will take a little bit of time to create the new project. Wait until it finishes. Once the new project is created, your screen will look like mine. In PSoC Creator, there are 3 screens that we're most interested in. The first is this one called Your Top Design. If you ever lose the Top Design window, you can always get back here by double-clicking Top Design over here in the Workspace Explorer. The second window that's important for us is the Pins window. Double-click on Pins to open up the Pin Assignment window. Here is where we get to assign which pins in your PSoC are connected to which pins you've placed in the top design. The third window that we're interested in is main.c. Find main.c in the Workspace Explorer and double-click on it. This window is where you actually write the code that describes what you want to happen when your program runs. Before we go any farther in writing our first code, we want to do a little test to make sure that we've set up the program correctly. Get out your PSoC microcontroller and the USB cable that came in your kit. We're going to first plug in the PSoC into the USB cable like this. Note that it's possible to plug the PSoC in upside down. So if you plug it in like this, it isn't going to work. You have to make sure that the copper traces on the top are plugged in like that. Next, take the other end of your USB cable and plug it into the computer that you are using to write the code. If everything's working correctly, your PSoC should have some LEDs lighting up on it. There should be 2 LEDs lighting up on this part. This part of the PSoC is the part that does the programming. And this part back here is the part that runs the program. So you should have two LEDs here and then one LED flashing back here. Now, in your PSoC code, click on the picture of the little chip that is labeled Program. If you get this window like we see here, it means that we need to select the correct device. You only have to do this one time, and then after that it will remember your selection and you won't have to do it again. To select the device, click on the Project menu and then go down to Device Selector. Now we're going to look for the device number. If you look very closely at your PSoC, this is going to be hard for me to show on the video, but if you look at this chip right there, up at the top of the chip, there's a little string of letters and numbers identifying which chip you have on this device. The device that you have is CY8 C5888 LTI-LP097. So we're going to scroll through this list until we find CY8 C5888 LTI-LP097, and then we'll click OK. Now we'll click on the Program button once again. When we do that, the output window down here will show us the progress of our programming operation. PSoC Creator will first compile the code and then program the PSoC. When it's finished, you want it to say, "Device was successfully programmed." If you get this, then that means that your setup was correct. We're going to move on and write an example program. In this program, all we're going to do is make the built-in LED on the PSoC flash on and off. Go to the top design, and on the right-hand side here, you'll see these menus of different kinds of blocks that you can place into the top design. We're going to go to the Ports and Pins menu and find something called a digital output pin. Click and drag a digital output pin and then let go of the mouse button to place a pin. Now I'm going to zoom in here so you can see what this looks like a little bit better. This represents one of the pins on our microcontroller. If you double click on this, it opens up a settings window where you can change different settings for this pin. The first thing I'm going to do is I'm going to change the name of this pin to help me remember what it is. I'm just going to call it LED for now. The other thing I'm going to do is uncheck this thing that says HW connection, like this. HW stands for hardware, and you want to have this checked in the case where you're going to be wiring this pin to some other block in the top design. I'll be showing you an example of that later. For now, all I want is a pin that I can control in my code. So I'll take off hardware connection and then click OK. So I now have this pin on my top design called LED, and it's an output pin, which means I'm going to be able to control whether the pin is on or off. And it's digital, which means I can't make it any value in between on and off. I can just choose either on or off. Next, we want to go to the Pins window, which is over here. Double click on Pins. And now in your Pins window, you see we've added a line called LED. Click on the Port drop-down. Here's where we can choose which pin on the PSoC this pin is going to be tied to. Select 2-1 like this, and then go to your main.c window, which might be open here in a tab, and you can click on it like that. Or if it's not up there in a tab, if you scroll down here to source files, you'll find main.c here, and you can double click on it to open the window. I'm going to start by cleaning up this window a little bit. All of these things in green are comments. They're things that will not be executed when I run this code. And I'm going to delete them in order to clean up this window a little bit. For now, I'm also going to delete this line called CY global int enable. This is a line that you need if you're going to be using something called interrupts. And for now, we're not going to be using interrupts, so I'll delete this line. I'll delete these comments and these comments. Now, I want to point out a few things about this code that you have here already made. First, you have a line with include project.h. Include lines are lines that load up libraries of functions that you want to use in your code. Later on, we'll include other libraries such as the math library to be able to do mathematical functions. For now, the project.h library is the only one you need. It includes all of the functions for interacting with the pins on the PSoC. Next, you have a line that says int main and then void in parentheses. This is a function in the C language. We'll be using C to program the PSoC. A function starts with a keyword that tells us what kind of variable is going to be returned when the function ends. Int refers to an integer. In this main function, we're not actually interested in returning anything at the end. And so we could either use int here, or we could use the term void. That means we're not going to return anything, but you can just leave it as int for now. Main is the name of your function. The function called main is the one that will run automatically whenever power is applied to the PSoC. So things that you write inside of the main function will execute automatically when you run your code on the PSoC. The word void in parentheses tells what kind of variables you're going to give to this function. Once again, we're not actually going to give any variables to this function. We just want it to run, and that's why we have void in the parentheses. We're not going to give it any variables for input. When you apply power to the PSoC, all of the code that's inside of int main, that is in between these two curly brackets here, will run just one time. When you get to this second curly bracket in the code will stop execution. You'll see that you also have a loop inside of main. This is a for loop, and it's been set up in such a way that any code that you write in between these two curly brackets will execute over and over again when you apply power to the PSoC. So let's try this out and see how it works. First, let's try turning the LED on and off just a few times. Before I write any code here, I'm going to go and click on the Build menu and then click on Build. In this case, mine says Introduction because that's what my code is called. And I'm going to wait until my code finishes building. The reason I do this is because I've placed some new things in the top design window, and until I click Build, my code won't recognize that I've placed those things in the window. So we'll wait until it finishes building. And hopefully it says Build Succeeded down here. If it says Build Succeeded, then you have no errors. Now, let's turn the LED on and off. I'm going to type the line LED underscore right, and then in parentheses 1. And I'll end that line with a semicolon. The LED part of this line refers back to this pin that I've placed in top design. If I had called this pin something else, like pin 1 or something like that, Then I would have to put pin 1 here instead of LED. This part of the line needs to be the name of the pin that I'm referring to. Write is a built-in function that is included in this project.h library. Write sets a value to a pin. The value 1 in parentheses is the value that I want to write to the LED. So this line, LED write 1, will write the value 1 or on to the LED. Next, I want to wait some time to leave the LED on. So I'm going to use one of the other built-in functions called CY_delay. CY_delay takes as its input an unsigned integer. That's what uint means. You can have that integer be as long as 32 bits. And it means the number of milliseconds that you want the code to wait before it moves on. So I'm going to put 1000 here to make the code wait for 1 second or 1000 milliseconds. After that second, the next thing I want to happen is for the LED to turn off. So I'm going to do LED write 0. Then I'm going to wait 1 second again. So this code will turn on the LED, wait 1 second, turn off the LED, and wait 1 second again. I'm going to copy this and do it a couple of times. So I'll paste it a few times. Okay, this will turn the LED on and off 3 times. I'll now click Build again to check to see if I've made any errors. If you get Build succeeded, that means that you have no errors. Now, this code will not yet be running on my PSoC. In order to get the code to go to my PSoC, I need to click on the Program button. So I'm going to take my PSoC and I'm going to make sure that it's plugged into a USB port on this computer. If you've unplugged your PSoC since we did our first test, plug your PSoC back into the computer now. After you plug in your PSoC, you should notice that the 2 LEDs at the front of the PSoC, the green and yellow LEDs, are lit. But the blue LED should be off since we programmed our PSoC with nothing earlier. Now, click on the Program button. After it finishes counting up down here and says Ready, the blue LED on the top of your PSoC should flash 3 times and then stay off. If you missed it and you want to try again, click Program again. The blue LED should flash on and off 3 times. Another way to get your code to run again is to press the Reset button on the PSoC. That's the button right here. When you press this button, your code will go back to the top and run again. Now, keep in mind that this code is running not from your computer, but it's running from the PSoC. Once we've programmed the PSoC, the only reason we need the PSoC to be connected to the computer is in order to provide power. We could, at this point, disconnect the USB cable to the computer, and we could peel off this plastic here, the plastic that's covering the micro USB port on the back of the PSoC. And we could apply power to this PSoC using some kind of battery. So I have here an external battery with a micro USB cable, and I'm going to plug this in here. And you'll see that our code ran just fine, even though it's not connected to the computer anymore. And I can get the code to run again by pressing this button. The reason why this is useful is because it allows you to be able to embed just this chip into your robot, and your robot can run as a mobile platform or something else that you don't want to be connected to a computer. Okay, now let's suppose that we want our LED to flash on and off continuously. In this case, copying and pasting the LED right 1, LED right 0 many times would be tedious and eventually fill up the memory of our microcontroller. So instead, what we can do is take these two blocks and delete them, and take just this one block that says only turn on the LED, wait 1 second, turn the LED off, wait 1 second, and I'm going to cut that and paste it inside of this for loop. The way this for loop is written says execute the code inside of the loop, and then when you get to this second curly bracket, immediately go back up to this first curly bracket and run the code again. And do that over and over and over again forever. Let's see what happens when we run this code. Click on the Program button, and then watch what your PSoC does. Instead of flashing the LED only 3 times, now it flashes the LED on and off indefinitely. If you hit the reset button, it will execute the code from the start again. Okay, let's try something a little bit more interesting. In your kit, you have a couple of external LEDs that you can connect to the PSoC, and you also have a resistor that you'll need in order to limit the current to the LEDs. So find these two LEDs and the resistor, and also find your solderless breadboard. One of these LEDs is blue and one of them is white. So we're going to go back to our top design, and I'm going to change the name of this LED. I'm going to name it Blue LED. Then I'm going to take another digital output pin, place it on the screen, double click it, and I'll name it White LED, and uncheck HW connection. Now you may notice here it says 2.1 in the square for the blue LED, and it says nothing in the square for the white LED. That's because we haven't assigned this pin yet. Let's go to the pins window, and this time, instead of assigning blue LED to pin 2.1, we're going to assign this to a pin that's not already connected to something in your PSoC. Let's connect it to pin 1.7. For the white LED, let's connect it to pin 1.6. Now we're going to go write some code. Since we've changed the top design and the pins since the last time we built this code, click on Build and build the code. Wait until it finishes so that it knows about the changes we've made to the top design and the introduction. You'll see that we get an error on LED right. That's because back in the top design, we changed the name of LED to Blue LED. So we have to change that name in our code also. For now, let's start by deleting these 4 lines of code. I want to write some code that will flash the blue LED 3 times and then flash the white LED 1 time. And I'm going to show you a couple of different ways to do that. So we're going to start with the way that we just learned. We're going to do blue LED, write 1, CY delay 1000, blue LED, write 1, CY delay 1000, and I want that blue LED to flash 3 times. So I'll copy that block and paste it 2 more times. Now, while I'm doing this, flashing the blue LED 3 times, I'd like the white LED to be off. So before these 3 blocks execute, I'm going to add a line of code that says white LED write 0. And this is supposed to be 0 here in each of these so that we turn off the blue LED. There we go. Okay, now I want to write 1 to the white LED then wait for 1 second, then turn off the white LED, and then wait 1 second. So if I only want the white LED to flash once, this will do it. Note that I don't have to write the blue LED off here because that's one of the last things that I did in the code before. So let's test this code. First, we're going to build the code to check to see if we have any errors. If you have some errors here, carefully check your code against mine and see if you can see any differences. If you have no errors, the next thing we need to do is wire up the PSoC. To do that, I'm going to first go back to the pins to remind myself which pins I set as the blue and the white LED. Let's build this circuit. Find your pack of male-to-male jumper wires and cut off this zip tie. Take 2 wires from the bundle of wires and take one of those wires and connect it to the pin on your PSoC that is labeled 1.7. You can see the labels up here at the top, and if you look very carefully, you'll see that the 3rd pin from the left on the top here is labeled 1.7. Plug in one end of your jumper wire to that pin. Plug the other end into row 1 of your solderless breadboard. In a solderless breadboard, all of the pins in a row are connected to each other, but the rows are not connected across this center. In other words, 1A is connected to 1B and 1C and 1D and 1E, but they are not connected to 1F, G, H, and so on. Next, take your other wire and plug one end into the pin on your PSoC that's labeled GND. You'll find that pin is the 2nd from the left, right next to 1.7. GND stands for ground. Plug this end of the wire into one of the pins on the ground rail. On the left-hand side and the right-hand side of this solderless breadboard, one of the columns has a red stripe next to it, and one of the columns has a blue stripe next to it. Oftentimes, we will use the red stripe to be power and the blue stripe to be ground. So by using a jumper wire to connect one of the pins in the blue stripe column to ground, will make all of the pins in this whole column all connected to ground. Now, I want to take one of my LEDs and connect it between this wire and that one. If you look closely at your LEDs, you'll notice that one of the leads is longer than the other. The long lead is power, and the short lead is ground. So the way we're going to connect this is I'm going to bend these leads a little bit so that they end up being about the same length, like that. Then I'm going to plug the long end into row 1 and the short end into row 4. The reason I didn't connect the short end directly into ground is because I actually want to have this resistor in between my LED and ground. The resistor serves to limit the amount of current that can go through my LED. If you don't use it, you run the risk of pulling too much current through the LED and burning it out. So before I actually plug this in, we want to go back to our code and click on the Program button to program the PSoC. If at the end of the output window it says that your PSoC was successfully programmed, take this resistor and plug one end into row 4 and the other end into the ground rail. Now, we don't know initially which of the LEDs is blue and which one is white. I happen to pick the white LED here, and in my code, I wanted the blue LED to be the one that's flashing 3 times. So I chose the wrong LED here. I'm going to take my other LED, bend it a little bit so that its leads are about the same length, and then I'm going to pull out the white LED and put the other LED in its place. Okay, that's the effect we're looking for. Now, let's see if we can hook up the other LED. I would like the long lead of this LED to be connected to pin 1/6, where the power is coming from for this LED. And I want the short lead to be connected through the resistor to ground. So I'm going to take this LED and the short end I'm going to plug into row 4 of my breadboard, and the long lead is going to plug into row 7. So I'll give you kind of a close-up here of what we have going on. It looks like this. Then I'll take another jumper wire, plug one end into row 7, and the other end into pin 1/6 of the PSoC, which is right next to pin 1/7. You should have the blue LED flashing 3 times, and then the white LED flashing once, and then the cycle repeats. If you're getting the right output, we're now going to go back into our code and change the way we're doing this whole cycle in order to learn a few more things about programming. First, let's create a variable that we can use in our code. Up at the top of int main, after the curly bracket, but before the for loop, type int I and then a semicolon. This is known as declaring a variable. When you declare a variable, you have to say what kind of variable it is. In this case, we've declared our variable as an integer. Then you have to say what the variable is going to be called, and follow your line with a semicolon. You could also give your variable a value to start out with, such as equals 0. It's good practice to declare your variables right inside of main and not, for example, inside of a loop. When you declare a variable, what happens inside the microcontroller is that a piece of memory is set aside for this variable. So if you have this declaration inside the for loop, you might end up setting aside many pieces of memory for only one variable that you're actually going to use. Now, instead of turning my blue LED on 3 times like this, I'm going to create a loop using the I variable. Here's how I'll do it. I'll start by setting I equal to 0. Then I'll write the line while, and then in parentheses, I less than 3, and then I'll put an opening curly bracket where I want the while loop to start, and a closing curly bracket where I want the loop to end. And right before that closing curly bracket, I'm going to write I equals I plus 1 semicolon. Now we can delete 2 of these blocks of code. And I'm also going to take all of these lines and indent them once. Now here's what our code says. When we get to the for loop, the code will first turn off the white LED. Next, it will write the value 0 to the variable I. Now, we'll check to see whether I is less than 3. It is, because I is equal to 0. So, it will run all of the code inside of this while loop. Turn the blue LED on, wait for a second, turn the blue LED off, wait for a second, and then make the variable I 1 bigger than it was before. So I will become equal to 1. When we get to this closing bracket, the code will go back up to the top of the while loop and check again to see if I is less than 3. It is, because I is now equal to 1. So the code will turn on the blue LED, wait for a second, turn off the blue LED, wait for a second, and then make I 1 bigger. So now I is equal to 2. At the closing curly bracket, it will go back up to the top, check to see if I is less than 3. It is, because I is 2. So then it will turn on the blue LED, wait for 1 second, turn off the blue LED, wait for a second, and then make I bigger by 1. So I is now 3. We'll then go back up to the top, check to see if I is less than 3. It is not, and so the code inside these brackets will not run. Instead, it will skip immediately down to the next line that comes. And the next line that comes is to turn on the white LED, wait for a second, turn off the white LED, and then wait for a second. Let's check to see whether this works. Click on Build to see if you have any errors. If you do have some errors here, carefully compare your code to my code and see if you can see the difference. If you get Build Succeeded, click on the Program button and watch the behavior of your LEDs. If you did this correctly, the behavior should not have changed. The blue LED should flash 3 times, and then the white LED should flash once. You can now make the blue LED flash any number of times you want by simply changing the value of this number. Try setting this number to 5. and then click Program. When you click Program, the code will build and also download to the PSoC. Watch what happens now. It should be that your blue LED flashes 5 times, and then the white LED flashes once. If this is working for you, I'm going to show you one more thing in our introductory programming session. I could use an if statement to include this line of code inside the while loop. I only want the white LED to flash if I is exactly equal to 4. So let's write that into this loop. If, then in parentheses, I equal sign 4, then opening curly bracket and closing curly bracket, then I'll take this line of code, cut it, and then paste it up here in the if. And I'm going to clean up the spaces here a little bit so we can keep track of this. So what's going to happen now is that I will start out at 0. We'll check to see if I is less than 5. If it is, flash the blue LED. Then we'll check to see if I is exactly equal to 4. If I is exactly equal to 4, we will flash the white LED. Now you'll notice that I use 2 equal signs here. One equals sign is what we use in order to write a value to a variable. For example, up here above the while loop, I wanted to write the value 0 to the variable I. But sometimes we don't want to write a value to a variable. Instead, we want to check to see whether or not a variable is equal to a value. When we're trying to check to see whether or not a variable is equal to a value, we do that by putting 2 equal signs. Click on Build and deal with any errors that you might have here, and then click on Program. Watch the behavior of your LEDs and make sure that the behavior didn't change. If you still have the blue LED flashing 5 times, followed by the white LED flashing 1 time, you have succeeded. Move on now to the next video, which will introduce you to Python programming.